Okay, so now we're going to look at some word problems, and we're going to specifically look at number 7 and number 10. I feel like you're going to be given more of those types of problems in your MyLabs homework. If you have your calculator, go ahead and get that out as well. We're going to try to do this only using our calculator so I can walk you through the steps. If you don't have a calculator at home, then you can use Desmos.com to help you out. Okay, so number 7 says if an object is projected upward from an initial velocity of 100 feet with an initial velocity of 64 feet per second, then its height in feet after t seconds is given by this function. Okay, so this function right here. Find the number of seconds it will take the object to reach its maximum height. And then what is the maximum height? So let's do a little sketch of this graph just so we can kind of understand what this is going to look like. So my y-intercept is 100 here. I can see that by looking at the c value. So what's going to happen is this object is going to start going up, reach a certain height, and then make its way down. Okay, so notice that I only drew in the first quadrant. The reason why I did that is because in real world problems, that's the only quadrant I'm going to look at most of the time. The reason why here is because my time is positive, and then my height, which is right here, s of t, is also positive. I don't really want my height to be negative, and I don't want my time to be negative. Okay, so let's get out our calculator. I have this emulator here. It's not exactly the way you will see it, but it's very close, so I'm going to use it. I'm going to go to the y equals, and I'm going to type in that function of negative 16, instead of t, use x squared plus 64x plus 100. Okay, and let's hit the graph feature. Oops. So like I said, this doesn't look exactly like yours, but you can see here, for me, I can zoom out, which makes it a lot easier for me to use this instead of yours. You need to change your y-axis. Okay, so let's go back. I'm going to tell you what to change your y to. So let's change your y maximum to something like 300. Okay, and to get to that, you need your window. So along the top, you see the y equals, the window, the zoom. Go hit your window button, and then change your y max to 300. Okay, it's going to look a little strange, but at least you'll see the top. Okay. All right, so I need to calculate the maximum height. So that will be the very, very top. Now for me, I can just click it and it will tell me. So if you're using Desmos, that's probably what you're going to see. You're going to see, if you click it, you have the x value of 2, the y value of 164. If you don't have Desmos, then what you're going to do is you have a couple of different steps. You're going to have to hit second, trace. This is your calculate menu. Okay, so second, trace, that's your calculate. And being that in this particular instance, we want maximum, you will go to maximum. Now, in the future, if you want other things, like you can have a value, a 0, which is your x-intercept. If you have a minimum instead of maximum. If you have two graphs, you may use intersect and see where they cross. That's probably all you're going to use in terms of this class. So go to maximum. Now this is going to sound a little strange, but you should see at the very bottom where it says left bound. About missed the T and left. So left bound. What that means is you are going to use your arrows, so your right and left arrows, to get somewhere to the left of your maximum. So in the picture, this is my maximum. You can pick any point to the left. Okay, just make sure you give yourself enough room. And once you're somewhere to the left of that, then hit enter. Okay, anywhere to the left, hit enter. And then now at the bottom, you should see right bound. So you're going to use your right arrow key, scroll anywhere to the right of your maximum. Give yourself plenty of space. Okay, press enter. And then guess, just press enter also. And you should see at the very bottom, it's going to say the word maximum, because that's what we found. And hopefully you got 2,164. Okay, so that's our answer. But let's put it in words so we understand what these numbers represent. 2 represented the time in seconds. The 164 represented the height at that time. Okay, so in words, this means that the object takes 2 seconds to reach a maximum height of 164 feet. Okay, so I'm also going to include some more videos on how to find this stuff into your calculator, because I know by listening to it, it sounds really strange. So I'm going to add videos on helpful tools so you can look at if you're still a little confused on how to use your calculator. Okay, but until then, let's move on to the last problem. Now this one has different parts. Every part is just a different type of question that you may see. That's why I want to do this one with you. It says a water balloon is catapulted in the air so that the height in meters after t seconds is this function. So just to kind of help me out like before, I want to sketch this graph. The x-axis is going to be my time. The y-axis is going to be my height in meters. Okay. Now I can look at this and see what my y-intercept is, so I know that's starting at 2.4, just like the last time, it's going to go up, 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 and then eventually it's going to make its way back down. Okay, so once again, I am going to, I'll use Desmos this time, so that way maybe you're following along. I'm going to hit start graphing. And let's type in the function. Okay, so I'm going to use y and x instead of h and t. So y equals negative 4.9 x squared plus 27 x plus 2.4. So the good thing with Desmos is that I can make it as skinny as I need to reach it. Whoop, there it goes. I can also use this little tool feature at the very top to change like my x-axis. If I don't want it to be negative 23, I can get to start at 0. Or let's do, I'll do negative 2. So I'll start at negative 2, and instead of it being up to 40, let's end it at 10. Look a little bit better there. Alright, so just so we can see, if you click on the y-axis, you see that 0, 2.4, that's the y-intercept that I sketched. Alright, so this should be fairly easy. For part A, it says, how high is the balloon after 1 second? So 1 second, I need it to be somewhere up here. Now, if you can't click it, it's because it's a decimal. Okay, so let's find 1 second. Oh. and you can get as close as you can to it. I got 24.5. Another way is in this function, I could just plug in 1 for x. That'll probably be the easiest way for me to look at here, okay, or look at my table. So 1 is 24.5. So my answer for part A is at 24.5, and the height is in meters. So you can do that by plugging in 1 where you see t, or you can use the table feature in your calculator. Okay, either one. Okay, for part B, it says, for how high is the balloon in the air for more than 30 meters? So this is a little bit tricky. Let's go back to Desmos. And I'm going to, in my second line, create another equation. Since I'm talking about the height being 30 meters, I'm going to set y equals to 30. That way I can see that it's going to hit 30 meters at 2 places. I'm not sure why it's not letting me select it. Here's one, and here's one. All right. So I want the approximations of those. Okay. So hopefully yours is better than mine, and you should be able to click where they intersect. Not sure why it's not letting me. Make this back an equation. Oops. Okay, it's not letting me, so I'm going to create it. Type it again. Okay, so y equals negative 16 x squared plus 64x plus 100. Oh wait, that's not the one I'm doing. I'm sorry, I'm looking at the wrong paper. We're looking at negative 4.9 x squared plus 27 x plus 2.4. There it is. Okay, so for some reason, if it has the table feature, it won't let you click it. All right, but now, look, I can click it, and that makes me happy. So it's going back to the question, it says, for how high is the balloon in the air for more than 30 meters? The points that we just found are called the intersect points. So if you're doing this on your TI, you're going to go to second, trace, intersect, and find those points. And once again, I'll put videos showing you how to do that. I want to make a note of what these values equal. So that's 1.356. So 1.356. And the other point was, let's go back, 4.154. Now it didn't ask for those specific times. It wants to know how high is the balloon, or how long the balloon is in the air for more than 30, right? So what I'm going to take is I'm going to take these two values and I'm going to subtract that 4.154 from that 1.356. And this will give me the time that it was spent in the air. Okay, so 4.154 minus 1.356 is about 2.798, and my units are seconds. So this is the time it's spent in the air for more than 30 meters. Okay. For C, it wants to know the maximum height of the balloon. So my maximum height should be at the top where you see H and K, but I specifically want K. All right, so let's go to Desmos. You should be able to click the top, and I only want the Y coordinate. The X coordinate is the time it took to reach that height. So I want that 39.6. So max height is 39.6 meters. Okay. The last one here is, when will the balloon hit the ground? So if I look kind of at my little picture, it starts, it goes up, and then eventually it's going to go down until it hits the x-axis. Wherever it hits the x-axis, that is also called 0. Okay, so I'm looking at where it's hitting the x-axis. Oops, wrong one. So let's go here. I can just select the point on the x-axis and it will tell me the second. So that'll be about 5.6 seconds. Okay, so this water balloon in 5.6 seconds will hit the ground and explode. Okay, so hopefully this kind of answers some of your questions on how to do this in Desmos or your calculator. I will post some videos, tutorials on how to find the intersection points, max, min, or zeros using a TI calculator. All right, thanks for watching.